which is used for quantum computing. So what's this fuzz all about? Let's check out what quantum computing is. The devices that we use in our daily lives, such as laptops, desktops and smartphones, belong to a category of computers called as classical computers. The computer chips used in these devices make use of something called as logic gates, which processes information in terms of zeros and ones. The logic gates are made up of transistors. The transistors work like electric switches. They either pass the current flow when switched on or stops it when switched off. As the technology is progressing, the size of these transistors are getting reduced. Thus, size of our devices are getting smaller and smaller. But how small can the size of these transistors be reduced? Is there no limit to this technology advancement? With the current technology trend, the size of the transistors will reach the size of an atom soon. On an atomic scale, the electrons exhibit a characteristic called as quantum tunneling effect. In simple words, what that means is the current flows through the switch even if the switch is closed. Thus, we cannot make this transistor size less than the size of an atom. So we have reached a final limit in classical computers. We need to look for a more efficient way to solve these problems in classical computing. The answer lies in quantum computing. Quantum theory is the branch of physics that deals with the world of atoms and the smaller or subatomic particles inside them. The laws of physics are different at atomic level, and the classical laws of physics that we can observe in our daily lives won't apply here. Quantum computers are the machines built on the principles of quantum mechanics that takes a new approach to processing information, thus making them super powerful. We know that the fundamental unit of processing information in a classical computer is a bit, which can hold binary values 0 or 1. Similarly, quantum computers uses something called as qubits or quantum bits to process the information. A qubit can be 0 or 1 or any value between 0 and 1 at the same time, thus making it superior to classical bits. This property of a qubit, which can be either 0 or 1 or any infinite value in between 0 and 1, is called as superposition. But when we actually try to measure the value of a qubit, its superposition collapses and it will be either 0 or a 1. So yes, quantum computing is a weird and difficult to understand with lots of math involved in it. When multiple qubits interact coherently, they can explore multiple options and process information in a fraction of the time compared to that of classical computing or even the fastest non-quantum systems. Qubits would have to be stored by atoms, ions, or even smaller things such as electrons and photons. There is one more weird principle in quantum mechanics, which is called as entanglement. What entanglement states is that two entangled quantum particles exhibit a strong correlation with one another. So what that means is, if these two particles, even if separated with larger distances from one another, if one particle changes its direction, the other particle also changes instantly. This means if we measure one qubit, then we also get some information about what will happen if we measure another qubit. The field of quantum computers is vast as it incorporates the concepts from quantum physics, superconductors, nanotechnology, and others. Each of these fields itself is a sophisticated field which is still being fully developed. So, building a physical system that follows principles of all these fields is a real challenge. The potential of quantum computers is tremendous, and we can achieve a lot that was thought nearly impossible with classical computers. We can synthesize new medicines, can develop new catalysts, accelerate the development of artificial intelligence, and a lot more.